Welcome to InCabin from the creators of AutoSens, connecting the global community of automotive interior specialists who are working on in-cabin safety, comfort, and productivity solutions through leading events and knowledge sharing. We are joined today by Abhay Rai, Chief Product Officer for Indie Semiconductor. Thanks for joining us today, Abhay.
Thank you as well, Sarah. I hope Carl doesn't feel too much pressure because of you being in the driver's seat.
We'll see if I can apply the pressure today with you, and we'll compare side by side at the soonest opportunity. So let's get started. I've got a whole list of questions for you. Of course, you guys are returning members of our AutoSense and in-cabin community. We're so thrilled to have you back this year. What sensing capabilities does Indie have today, and what differentiates Indie?
So, as you know, that India is 100% automotive-focused semiconductor company. We are a pure-play semiconductor, and we are probably the only semiconductor company that is focusing on all the sensing modalities. So we have ultrasonic in production. We have a bunch of vision products in production in every single automotive application. We are going to dominate the automotive world with our differentiated FMCW radar solution. And we are simultaneously developing the technology for 77 gigahertz as well as 120/140 gigahertz. And then we already have FMCW LiDAR in sampling. So what differentiates us? So number one is we have every single sensing modality under the roof. And second, our design philosophy. So because we are 100% automotive focused, we solve these sensing challenges from first principle perspective. In other words, what we do is we use common design practices that scale the sensing modalities from one to other, and how it solves the problem. What it allows the end consumer, tier ones and OEMs to have a true software portability because, so for example, if you look at vision radar and LiDAR, for example, the sensor specific processing is different, but underneath SoC capabilities, real-time subsystem or safety and security functionalities are very common. So if we provide a unified platform that allows the software to easily scale from one sensing modality to other, and that's probably very unique to Indie.
Do you have a lot of customers that come to you with sensor fusion challenges? Is there anything unique that you, just because you are able to support all of these different sensors, is there anything unique and because of your focus on automotive purely, that you're any unique sort of conversations or challenges that you're helping OEMs face or tier ones face when you're working with them on sensor fusion?
Yes, absolutely. So sensor fusion is the biggest pain point right now in the automotive space.
Yeah.
So as far as the architecture today is concerned, the sensor fusion, it doesn't happen, or it happens in a very rudimentary way. In order to solve the sensor fusion challenge, end customers, OEMs, have to kind of put a bolt-on architecture. And right now, sensor fusion is addressed as an afterthought. And why I say this, like if you look at various challenges across the sensor fusion, radar and camera fusion doesn't work mostly. And why I'm saying this, because if you look at, for example, parking, automated parking, it doesn't work in most of the cases. And the reason it doesn't work is we are not truly able to take the complementary sensors' full potential, for example, radar and camera, and fuse them properly the way they need to be solved. Like, for example, if radar is your primary sensor, radar detects an object, And then camera, because it has a very high resolution, it can provide the region of interest um, um, for the object of interest. And then if you fuse the data, you will be able to achieve the real-time sensor fusion without burning much of the power and without burning much of the compute. This is absolutely not being done today. And that
Okay.
is the problem that need to be solved for the front sensing, for the surround sensing, even for the front sensing camera to camera as well. Like for example, front camera that is doing the highway pilot and front camera coming from the surround view. If we can do the fusion at the lane level, then we can do much more seamless handover between highway pilot and traffic jam pilot. That's not happening today.
Okay, so your argument would be in favor of edge computing and then sending to a central processor, or do I have that backwards?
So immaterial of edge processing and central processing, the first thing that need to happen is how do we incorporate the heterogeneous sensor modalities, and then how do we look at the data, right? And then where do you process it really doesn't matter. But just to respond to your question, I think the edge processing and central processing, none of them are doing their job. And therefore, first of all, like the market is really underserved in the edge processing category. And therefore, everybody
Oh,
thinks that, okay, if I transport the data to central processor, I will be able to take care of it. However, the sensing need is very different across the vehicle, right? Like in the front, the sensing need is totally different from the back, from the side, and in cabin.
yeah.
So if you have a proper edge processor or a zonal processor that is able to handle multiple radars and multiple cameras and able to do the real-time processing, then of course edge becomes much better from the cost perspective, from the latency perspective, and also from the true sensor fusion performance perspective.
Very interesting. Yeah. What role would you say multimodal sensing plays in the next generation of vehicles?
Hmm. So the true challenge right now is these sensors, for example, radar, LiDAR, and camera, they're very complementary in nature. One's weakness is another one's strength. Like for example, if I talk about radar does the 3D sensing. It also detects the velocity in real time. So in many cases, radar becomes a primary sensor or the first sensor that detects an object. And then camera is a great sensor for classification and identification. When it comes to LiDAR, LiDAR is very interesting, right? So when you bring the LiDAR in equation, forget about the cost. Cost will fall in place if we can truly solve the LiDAR challenge. But the real thing is, in order for LiDAR to become an important sensor, it has to solve the problem that a radar cannot solve and camera cannot solve. So in other words, if I turn off radar, can LiDAR take over? And the answer is no, not at least today's LiDAR, which is coming from time of flight perspective. The time of
Mhm.
flight LiDARs cannot take care of it because there is no way you can detect the absolute velocity. So if you cannot detect the absolute velocity, LiDAR cannot replace radar in case radar fails on the road. And that has been the tremendous challenge. You go through all this pain, you put the big box on the top of the car, and if it cannot detect the absolute velocity, then that's not truly a redundant sensor. In order to detect the absolute velocity, LiDAR has to go to FMCW. And then you
Oh,
achieve,
okay.
then it's purely a cost problem. Technology is there and you have to take care of the cost. So this is where industry have to go, and this is where we are doing our bit. So what we did is we designed a FMCW LiDAR SoC, which is sampling now, and it has huge interest from OEMs across the world. We are very closely working with several OEMs to enable that. In order for FMCW LiDAR to work, you also need highly linear laser, and that's why Indie also acquired Terexian about 3 years ago. That has the best linear laser in 1770 nanometer category. So we combine all of these technologies together, and that will deliver a truly redundant LiDAR.
Is there more that we should know about Indie's unique offering in multimodal active sensing?
Absolutely. So let me just say one thing, right? In last 3 years, our revenue has grown by 10x. We are the fastest growing semiconductor company on the planet. And 3 years ago, our ADAS revenue was zero. Last year, our ADAS revenue was 50% of total ADAS revenue. So whatever we are doing, it's very differentiating. Our customers appreciate that differentiation, and that's the reason why they want to work with us. So I'll start with vision. We are very dominant in the vision processing. In fact, in the in-cabin space, we have about 40% market share today for the next generation products. So where we are going, like I'll start with the in-cabin, which is the biggest challenge, right? So there are tremendous amount of innovation going on there, where you have to detect the drowsy driver, distracted driver, occupants, the trapped passengers, or you can name all of it. So therefore, that camera is very special. So industry initially started global shutter monochrome camera for driver monitoring, but for in order to address the next generation problems, the industry is going from the monochrome global shutter to RGB IR. And RGB IR camera is very special, but it's also worst of both worlds. It's worst for RGB production, and it's worst for IR production, because the system MTF requirement is very challenging. So what you have to do is you have to extract RGB from the RGB IR in such a way that your color performance is at least on par with the regular color camera, and your IR performance is on par with the global shutter camera, so that the algorithm providers for DMS can take care of the algorithm, and the algorithm works. In order to do that, you have to maintain the system MTF, and you have to extract RGB and IR properly. So this is our bread and butter. What we are doing is we are extracting these two in such a way that the native resolution is maintained for RGB and IR both. Once you do that, then basically you can take care of all the cabin processing, also some of the convenience features like video chat, and you can run the CNN algorithms on the IR feed or RGB feed with the ease. So that's what we are doing there. In case of exterior sensing, for example, ADAS, there are several challenges. So the way camera processing industry have grown is RGB was the de facto sensor for cell phones, but automotive industry is very different. Automotive industry needs an ability to detect the object under extreme low light condition and also extreme bright light condition. And they are not orthogonal to each other. Sometimes you have a very dark scene, sometimes you have very bright scene, and sometimes you have dark and bright scene that coexist within the same frame. In order to make sure that you detect the darkest and brightest object in the same scene, you need to have a much wider dynamic range. So we are the only ISP on the planet that can deliver 144 dB dynamic range, and therefore we are the only company that can process any camera, automotive camera in the world, whether a split pixel camera, single pixel camera, it doesn't matter what kind of conversion gain it has. And we are able to produce the picture, not just a beautiful picture for the display, but also the picture that has contrast enhanced frame that can directly go to the CNN engine for the processing of object detection. So that's a big challenge for industry. So as a result, in IND 880, which is our next product, we completely redesigned the image processing pipeline in-house. So HDR is one. The other thing is automotive cameras are very weird, right? So like, for example, they're not RGB. Sometimes you use 2 clear pixels because they're much more sensitive. So RCCB, RYYCY, RCCG, these are the very common color filter arrays. But I'll give the example of RCCB, for example. If you use RCCB, like for example, Tesla is known for using RCCB. There are other customers who use RCCB. RCCB is great for low light. However, that's the pixel which also saturates first. So composing a HDR scene with RCCB is absolutely difficult, and nobody has solved this problem yet, including Tesla. We are the only one that have solved the problem. And why I say this, because if you look at the picture coming out of Tesla cameras, because certain colors saturate faster, and because you are compromising on the delivery of true color performance, there is no way you can fully reproduce red and orange color. So like, for example, if the camera looks at a traffic light, red looks like an orange. And
Okay.
that's a big challenge because that prohibits your ability to truly reproduce the colors. And in some cases, it becomes a safety challenge. We can fully reproduce the colors without any artifact, without loss of any color or without any artifact. And we can do this at lowest power in real time. Nobody else on the planet can do this. So, and that differentiation is not just common for the video processing at Indy. Similar differentiation we brings in the radar and LiDAR. We are truly an embedded company. So as of today, across any of the product lines, we don't use external memory for any processing. So because we have developed an embedded architecture where we can process all these sensors line by line, number one, we can produce the sensor performance real time. Number two, we can do it at a very, very low power. And that is something which is required for the industry.
You hear more and more on the in-cabin side too about how important it is to be low power. I mean, of course, it's been a huge topic of conversation for AutoSens for years, but I've been, I guess, unsurprised to see how prevalent of a topic it is on the in-cabin side as well, especially with all of these displays we have going and all of the other kind of electronics that are being added to the car for sort of the comfort and the convenience and the excitement features. So yeah, obviously you guys are well equipped to handle all of those scenarios. So how are you shaping this product line, and what should the automotive industry expect from Indy in camera-based SoC space?
Absolutely. So the video space is very interesting. As I was mentioning, that the video processing for automotive is overly underserved. If you look at the players that are doing the central processing, they have rudimentary color processors or video processors, otherwise known as ISPs. So let's start with the trend. So because camera is a sensor, nobody can live without in the automotive space. So where the camera is going, so number of cameras are increasing in the car, resolution is increasing, and the use cases that are coming now, they require every single camera to have sensing and viewing feature both. So as a result, the camera stream need to be processed not only for the display application, but also for the computer vision application. And computer vision requires a very, very different type of processing. So, for example, CNN doesn't care about the pretty picture; they care about just the contrast. So, um, as the first goal, our video processors, what they are doing is we are developing the video processor that can handle multiple cameras at the same time, at the real-time basis, where not only you can um, you can program the ISP in such a way that it can handle multiple cameras, multiple resolutions, multiple frame rates, but also you will be able um, to program the ISP frame by frame. You can use different context without dropping any frame. That's a required feature. Um, Otherwise, how industry have been doing is if they have to process the color, they'll take the whole frame and put it into external memory. Um, and it goes in and out of memory several times. The challenge with that approach is there's no way you can guarantee the latency if you have to take the frame into the frame buffer. So as a result, by the time the frame goes to the external memory for CNN processing, there's too much jitter into the system, and that has been the primary reason for reduced performance of CNN engine. So basically, it reduces the detection performance of CNN engine. So the first thing we have done to reduce that is we have made our ISP a real-time processor. So our ISP doesn't require any frame buffer. It can process any scene line by line. So as the data goes in real time, it goes out. So if you look at the total ISP system, our latency is less than a millisecond, which is really revolutionary. So what that will do is that will take the burden off of central processor or even off of the edge processor. So that's first thing. Second thing is if you look at the system, um, even today, these sensing systems are very fragmented. So what we are doing is we are solving some of the challenges at the system level. So what are we doing is apart from the ISP, we are adding the real-time subsystem and SoC framework into that. And as a result, not only we will be able to process the camera, do the object detection, but also we will be able to host the application. And as we maintain this same application and safety fabric across the sensor modalities, we will be able to have the software code that can go across the sensing modalities. So as a result, what will happen is there is a lot lower cost of development and a lot lower cost of deployment. So several things. One is at hardware level, because we are adding a lot more features and we are reducing the power. The total system design is way less complex, and even handling the thermal is a lot easier. So even when a tier ones build a box, the cost of development and deployment is very low. When it comes to software, because we are putting the unified SoC fabric, the cost of developing software and maintaining the software also significantly goes down. So as a result, even our entry and mid-level vehicles can afford these sensing systems, which was otherwise not possible.
That's so important, and it's so important for the average person and the average consumer to be able to have access to excellent technology inside of their vehicle. And it's obviously not even a question of whether they should have access to any of the safety systems for vehicles. So it's really great to have companies like you in the industry who are focused on all of the right things, not just having the right technology, but also aware of cost and how cost and power play a role in the entire vehicle as a system and not just the individual sensors or components. What a great talk. Thanks so much for meeting with me today. Is there anything else we should know about seeing you in Detroit or Barcelona this year?
Absolutely. So we truly believe in AutoSense, and we will continue to participate and do our bit AutoSens is a great conference. It's designed for engineers. Engineers love the conference, and Indy will continue to be there, and not only continue to be there, but we will try to even grow our presence.
I've heard, and I'm very, very excited to see what we have with you in Barcelona this year. Just heard little whispers and rumors. I won't say anything on camera. And of course, we're really excited to see your team in Detroit as usual as well. To find out more information on Indie Semi and to find out more about our upcoming events, see the links in the description or visit InCabin.com. That's InCabin.com. And for more in-depth interviews like this, subscribe to our YouTube channel and follow InCabin on LinkedIn. From the Twin Cities, on behalf of InCabin, I'm Sarah Sargent.